My name is Jan Vidar. You can call me JV. So say hi, JV.
Hi, JV.
Oh, one more time, please. Hi, JV.
Hi, JV.
Ah, there you go. I'm sure a lot of you have been sitting down for quite some sessions today already. So I'll try to do this a bit different than most, I hope. I will show you some code. I will show you some stuff, and I will talk about things that I think most of you don't think about too much every day. So I will talk about application shielding. Does anyone actually know what that is? Okay, one guy knows. That's cool. I heard someone actually whisper security, and you'd be right. It has definitely something to do with security. But if we can look at what others are saying about it, it's more a discipline of security, which is an ever kind of evolving thing. So let's talk about that. But first, who are we? Who am I? And why am I talking about this? So I'm from Promon. We are a Scandinavian-based company based in Oslo. We do application security for banking, financial, authentication applications. That's where we started. And now everyone is thinking, oh, banking grade security, now that's exciting. Banking grade security, that's exciting. Okay. Well, it can be. That's our bread and butter. We're also doing other types of application security as well. And I don't know if you remember this guy. No? Okay, some do. So we discovered some vulnerabilities in Android. I don't think this was ever fixed. And then we discovered this vulnerability a few months after. This one was actually fixed by Google. So I think what we do is essentially find and identify security flaws and then try to work out how can we address them from an application point of view. How can we make the application by itself being resilient against certain types of attacks. That's what we do, and that's what I'm going to help you to do today as well. And I will not do kind of a sales pitch today, but if you want to meet us, we have a stand downstairs. That's my sales pitch. So talking about app security, app shielding, I think it's important to separate them into a couple of different types of application security. And I think there's quite a lot of ideas that are around what is security, and I'm sure some of you have some ideas that security involves stuff like encryption, and you'd be right. Maybe it does something to do with malware. That's also right. But it's a lot more than just that. So I would like to categorize some of these things into two main categories as I see it. And that is at-rest security and runtime security. Any idea what's the difference? Oh. So I think if you look at your application, what kind of at-rest problems might exist. I will actually show you a couple of concrete examples afterwards that relates to this and other things that we have been working on. But I mean, someone might basically take your application, download it from Google, download from the Play Store, and basically start picking it apart. It's easy to decompile for the most part. Then you can figure out what is it doing. Then there are things you can do to make that difficult. We'll take a look at that. The point is, you can basically understand the application enough so that you can extract data from it or figure out how to manipulate it. This is a real thing. It happens. Show you some data on this in a short while as well. And then you can repackage it. You can modify this application. I'll show you how in a short while as well. And then you can, of course, extract the data that the application has stored on the device. And that has some really, really nice consequences depending on what you want to achieve, or bad ones. So if you want to back up your device, it's kind of nice to be able to do that, but you might break some sandboxing in the process. So if you move to the other aspect, which is more the runtime attacks, these are the things you can do while you're running the application, which differentiates it from the at-rest attacks, where you don't actually have to run it. You just need to download it, and you can take a look at it. So what we see is that there are a lot of different types of malware using this kind of attack. And of course, if you are working with a penetration tester, they would be doing this. If you are working and are actually experiencing fraud or different types of attacks, they are all doing some kind of runtime attack. I think they probably would prefer just doing a repackaging of your application in the first place, but if that doesn't work, then we would have to attach something to it. What's easy to do is attach a debugger. Then you can try to put some breakpoints in there and figure out what's really going on. You can attach Frida. Anyone used Frida before? A couple of hands. Yeah, nice. So you know what you can do with Frida, essentially. I will not actually demonstrate that today, but it's an immensely powerful tool which you can both use as a debugger and a testing tool, but you can also change the behavior of the application at runtime. So that's something we don't see that much in malware, but we see it's happening from targeted attacks. And I think a very, very important part is UI security. How do you know that when you pick up your phone and you go to your messaging app to send a message to your better half, how do you know you're actually sending it to her or him? Well, because the UI said this was the person I sent it to. So there is a potential problem that the UI might tell you something, but what's happening is something else. This is a fundamental problem in all sorts of applications, which are not trivial to detect, and it's not obvious what you can do about it. But there are things you can do to make it more resilient, for sure. This is also where Strandhog comes in as an attack, where basically you can inject a activity into another application, which is not your application, but it looks like it, and you have no way as a user to basically determine that actually that's what's happening. I'm not actually interacting with my application, I'm interacting with a different application. I'm sure some of these things are just words. I'm not sure if we should go through all of them. We can, but I think it will take a lot of time, maybe. But I think the most important thing is that your application contains lots of different parts. many more parts than you'd like to think about yourself, which means that your attacks surface for this application is a lot bigger than what you expected, maybe. And what I mean by that is your application does contain some code that hopefully you or your team wrote, and then it contains some code that you basically included as dependencies. And then it contains some code that basically were there from the operating system, some code that were there from the device manufacturers. And all of them can be attacked in different parts. And how do you safeguard against that? I think that's a fundamental question you need to ask yourself. And then ask yourself this: do I need to protect myself against this? At the end of the day, it's not your device, it's your end users. So your application contains lots of different code. If you are using a web view inside your application, now you have a web view that can be attacked, manipulated in different ways. But also your application is doing stuff like the system libraries. They can also be attacked in different ways and manipulated to make the application do something different. So if we talk about the Android security model, or what I think is more the modern application security model, I think the most important thing that was done on these devices were the sandboxing, which basically means that one application do not have access to data from another application. And of course, they can be restricted in what they can do. So how is this different from the desktop model? Well, I think if you look at the history of this, in the Unix desktop, it was more about how do we protect one user from accessing the data from another user. And then fast forward a few decades, and then we have lots of different applications, and everything exists within your own desktop space. And I think this one has been really successful on Android and iOS and Windows Mobile, for those who remember that. But there are some questions. There are some issues with it. Is it still safe to download random software from the internet? My father got this advice 20 years ago: do not download stuff from the internet. And he still calls me whenever he needs to install an app. And does malware exist on Android? I think you know that the answer is, well, it depends. I mean, you have to jump through some hoops to do it wrong right now. You have to enable side loading if you don't want to go to Google Play to download stuff. And of course, Google has this scanning capabilities where they are protecting your apps. But Google is not everywhere, and it's not everything. So who here is using a non-Googled phone? Wow, maybe one. I mean, in China, there are no Google phones. So who here are publishing apps in Google Play? Quite a few. That's nice. Who is publishing apps, the same app, in non-Google Play? Handful of hands. So if I told you that your app is available in at least a dozen different app stores in China and other markets, would that surprise you? And you didn't publish it there, someone did. Maybe they modified the application somehow. You don't know. There are things you can do to make it more resilient, to prevent this from happening. Or maybe you want to allow it, but at least make sure that no one is tampering with it. But I think, all in all, when it comes to the sandboxing, it basically boils down to breaking the sandbox. That's your mobile threat number one on Android. And I think there are a couple of ways to do that. Privilege escalation being one. You can root your own device. So how many has actually done that? Okay, maybe a dozen or so. So I think there are lots of nice things you can do when you root your phone. You can look at stuff. It's very, very interesting for us to be able to pick apart code, look at what kind of data do they store. Are they actually encrypting data? Things like this. But you can also do more practical stuff like cloning your device, copying it. Whenever you get a new device, you have to basically reinstall all these different apps, and then you have to recover all this data, which cannot be recovered, and you have to log into maybe a dozen or 24 different applications. And if you root your device, you might be able to save some time there, because we can look at all the private data that Android does not want you to look at. So this is one example of a privilege escalation, but also an application can do that, can root your device. And now the application can look at all these files that you have stored, can look at all your pictures and everything you learned about the storage APIs in the previous session. Well, that's nice, but you don't have to. You don't have to deal with those limitations if you do. So I think a lot of these problems would go away if rooting did not exist. Unfortunately, it does. And please don't go rooting someone else's device. So, I mean, if you go to the OWASP mobile top 10, there is some really, really good advice on what you can do to protect your application. And one of the things that it does say is that maybe you should check if your device is rooted. And then you can protect your app and basically prevent it from working. And then you would come up with some code like this. And you can add this kind of safeguard to it, which basically says that I don't like it when you are rooting or using a rooted device. So I'm not going to let you do your financial transactions or play the game on this device, because I don't like people from cheating or scamming, doing stuff like this. And this is a pretty naive implementation, which I think quite a lot of you probably have done something like this at some point, or use a open source component that does this. But, I mean, I can fix this code. There we go. So how can we prevent this from happening? I think there are lots of different things you can do. I think if you are going into the market, or if you have some ideas, ask some security experts. They will probably lead you in the direction of, you definitely need obfuscation. Probably, maybe. So obfuscation would make it harder to find the function that determines that my device is rooted. But that's it. So there is no simple solution for this, but there is a lot of stuff you can do to make it slightly harder. So you can verify the signature of the application has not changed. That means no one has actually manipulated the application and is basically running a different application. That's one concrete thing you can do. However, if you do the most simple implementation, you would end up with a similar function which says is repackaged and return false. But if you do that, you would be in the half of the apps that is doing better than the other half. We will take a look at repackaging specifically in a short while. The other thing about the sandbox is how can you work around it? And I think quite a lot of the data protection that you have in place already is working quite nicely. But there are accessibility services that can read all the content on the screen. I think most of you are thinking about accessibility services as kind of text-to-speech services that can read content from the screen, maybe. They can. And the user have to enable them explicitly for it to work. But there are lots of other use cases for accessibility services. Examples being password managers. They would read the content, figure out which application are you using, which view are you looking at. In this case, I'm going to put in and enter this specific password. Now that's awfully nice. The problem is when you are enabling all these services and are basically opening up for lots of different types of useful screen readers like this. They can also, you can also fool users into installing different types of screen readers that do malicious things. We have seen some concrete examples of payment applications where you are opening up the payment application. You are basically authenticating yourself, maybe with biometrics. And at this point, the screen reader kicks in and basically changes the payment account numbers to point to some other account number, and then it's actively hitting the send transaction button. And it's not breaking any laws or rules. The sandbox is still there, it's still working. And this is most of the Android malware that we see today, screen readers or accessibility services, for the most part. Then, of course, there's the factor that you can't really rule out. I mean, we found Strandhog, but there are probably a lot more of these. Simple kind of exploits that aren't really exploiting stuff and isn't really breaking or rooting the device in different ways. And of course, the Strandhog attacks still work on older Androids. So unless you require Android 10 and above, then you are pretty good. Otherwise, we have some advice on our website for what you can do to protect your own application by doing some changes to your application manifest. So I spoke about how can we do this, and if you want, you can take a look at our YouTube video. It's a bit dated, but we demonstrated how can you actually steal a Tesla, and it turns out that it was remarkably simple. The authentication token was stored in plain text on the device. And once we get access to that, you can basically unlock the car. And now there were some extra hoops. You actually needed to re-authenticate if you wanted to drive away with the car. But if you have access to the device by using a privilege escalation, you can change the application. You can change the application in such a way that when you are re-authenticating, we're sending all the credentials home to us. And at this point, we can basically follow this car wherever it is. We can follow it on a map, and we can figure out when it's parked, and then we can go up to it, unlock it, and drive off. I'm not picking on Tesla specifically here. Tesla was probably the first to do this kind of functionality in their cars. And this has, yeah, some years have passed, so maybe this doesn't work anymore. We haven't tested it again for some years. So obviously, if you can repackage the application, you can change the application, and the application does not care or does not react to it in different ways, then we can do these kind of things. And now we're coming to this point where you can unlock your house with an app. You can locate and find your kids with an app. So everything becomes a lot more target-rich. And the checking of the whether or not this app has been manipulated is a relatively simple thing to do if you are buying an off-the-shelf solution. Otherwise, you would have quite a lot of work trying to keep up with it, but it's possible. I know that quite a lot of big software houses are doing a lot of things here to make some of these attacks harder. And I think also Tesla has done some things on their side, so let's not focus too much on them. So we're doing a mobile threat report, which will be out in a few days, where we have looked at the banking and financial apps globally to see, do they have any kind of protection against tampering at all? And if so, how resilient is it? We didn't actually go that deep into how resilient are these apps at this point. But we looked at very, very simple things. Can we actually change these applications? Do they still work? How do you trust that your money transfers are going where you want them to go if you can change the application? So we looked at, I think it's 100 to 200 apps. Actually, it was 103 apps, which were basically grabbed from Google Play and Sensor Tower. Can they be modified? And the result is that 46% of them could be. No issues whatsoever. And then we can break it down into what kind of applications are more secure by category or things like this. But these applications are available also from non-Google Play app stores. I'm sure that quite a few of them have not been published in these app stores by themselves. So I think that the key takeaway here, though, is that the application has lots of different parts, not just your code. There are things you can do to make it more secure. I think follow the OWASP guide, Mobile Top 10. And I think that's a really, really good start. And if you decide that you don't want to do this yourself, you can look at least 2 different sponsors of this conference today that can help you. And that is me being not salesy. So, thank you. I think we have some time for questions. And also come by our stand and solve our wrapper or malware quiz. So we have quite a few minutes for questions. So please go.
Any questions?
We have one over here.
You mentioned the OWASP top 10 for mobile. Is the last I'll try and raise my voice because the microphone's just out. So the OWASP top 10 was last published for mobile in 2016. Is that still relevant today? Is the reason it's not changed because the threats are still the same?
Okay, so the question was, is the OWASP mobile top 10 still relevant as it was published back in 2016? And the answer is yes. I think those guidelines are spot on. I think also the Android ecosystem has grown and matured quite a bit since then. A lot more security has been implemented, and especially in the privacy area, which is making things a bit harder for you to do certain checks, maybe. But I think the threats are still the same. Yes. Two questions over there.
Are there any additional security threats when development SDK can be integrated by?
Okay, so the question is, if you are developing an SDK and integrating that, or someone else is integrating that afterwards, are there additional security problems? Yes. So one of the things, one of the challenges with integrating or securing a SDK is that you don't really know what the entire final application is going to look like. So if you're doing clever things like looking at whether or not the application has been signed correctly, then you don't really know that up front. So you have to do slightly different things to achieve something like this.
Is there a way how to protect the against accessibility feature without making it hard for the disabled people?
Is it possible to protect against accessibility services without making it difficult for people that rely on accessibility services? Yes, but there's always a but. You probably need to know something about the accessibility services that you like, which means that you can look at which accessibility services are active, and you can decide whether or not you want to send data to the accessibility services based on that. And then, obviously, if you like certain things, then you can do this from inside the application.
So my question is, how important are vulnerabilities found in Java libraries used by Android applications? When the apps are sandboxed, is this a real threat?
So question is, are Java vulnerabilities or library vulnerabilities inside sandboxed applications, are those a threat for the application? Well, I think for the application, it can be, depending on how the application is using those libraries, of course. So quite a lot of the applications, when they're using certain libraries, even though there might be a security problem inside that library, they might not use it in such a way that it's exploitable. So then it might not be a problem. And then, of course, the other aspect, depending on how this application can be, are using this library, it can do certain things. That it can do privilege escalations and things like this. But again, it depends on a case-by-case basis.
You mentioned some attacks that use overlays over apps. And there is a system feature that disables the overlays. Is that a sufficient kind of protection, or can that be bypassed?
Yes, so the question was about overlays and the existence of system functionality that allow you to block events from, or if there is an overlay of your application, and is that sufficient? I think it depends a bit on the case, but I think for the most part, yes. So a common overlay that kind of existed and was popular some years ago was the Twilight application, which would do kind of a blue filter functionality. And this stopped working after you enable those flags to do not allow interaction with the application if there's another application in front of it. But if you don't use it, what you can see, what we have seen in the past, is that you can trick the user into clicking a button that you are drawing, click here to accept, which can be hidden by this other button that says, go back, do the save thing. And then you can trick the user into enabling things or disabling things that he or she shouldn't do. So there are system features that protect, and I think those are sufficient in most cases.
And is there a way to protect against these attacks without using the system, without blocking the overlay?
Is it possible to do this without blocking the overlays?
It's possible to protect against these overlay attacks without using that system feature to block all overlays.
That's a good question. I can't answer you offhand. Maybe. But come by. We have some experts. There's a question in the back.
So, is it a memory space safe on a non-rooted device? Like a runtime memory, of course. RAM. Is it safe on a non-rooted device, like to not be tempered?
Yeah, that's an excellent question. I think you can start with the premise that you don't really know if your device is rooted or not. And if you take that as a premise, then the answer is probably no, which is kind of painful to think about. But if you know that no one has access to it, then I think it's safe to assume that no one is tampering with your memory.
Yes, so it's all about detecting if the device is rooted or not in this case.
Well, I mean, even if your device is rooted, that's not indicative of anyone actually tampering with your memory. So it's whether or not the device is rooted or not is definitely a case where that could be the case. But so is all the other cases as well. One more.
As a clarification, this example is rooted.
Yes.
You're saying not to check for the rooted phone, or to check and still take into account that maybe the result is that false.
Well, I'm not saying that you should not do this. I am questioning whether or not it's actually helpful. I think if you're looking at the privacy aspect of this, I know that Android has been flip-flopping a bit back and forth whether or not to allow certain applications to have access to the system directories. And then the question is, what happens if you don't can access these files? Does that mean they are not there? Or does that mean they are there, but they're trying to hide the fact? So I think checking if your device is rooted, if you find these, then you're definitely on a rooted device. If you don't find it, you might be on a rooted device. All right, then I think it's our time. So thank you all.